The broadcast is now starting. All attendees are in listen-only mode.
All right, folks. Hello, this is Tom Dubek. If you can hear me, please raise your hand. There's a little hand icon. Click it so that way I know it's coming through. And this way you can find it to answer questions and things. Fabulous. Fabulous. So people can hear me. All right. Now we have a large crowd tonight. We had nearly 90 people sign up for this. So we'll get more than 30 that will probably end up attending. And I think we're at 34 right now as I speak. I just went to 35. So, we'll give everybody, normally we'll start right at 8 o'clock or try to be close. I do another webinar right before this for pro gamers. And so I need a little bit of a break after teaching all day, then doing the other one. I take a little break in my voice and we'll get started here. Okay. So the hands. Leave your hands up, folks. I'll put them down just because it allows me to get a sense. So if you can all hear, raise your hands so we get everybody set. All right, great. Please raise your hand if you can hear me. All right, great. Now I'm going to put everybody's hands down since clearly the hands, I can see everybody's hearing me. There is a place to write questions. We will try to pop those. I've got two computers. I'm looking at now. Put one screen. Computer will be looking at questions. I'll try to keep looking at them right there. And I'm going to put everybody's hands down for you. There we go. Good. Now, what I would like to know is a couple questions about you, and then I'll tell me about me, and then we'll talk real briefly about the event, and we will take it from there. Now, if you'd be so kind, raise your hand if you're a teacher or a coach. First of all, you teachers and coaches, thank you for giving up your Tuesday night to do this. Appreciate it. The kids do. All right, I'm putting your hands down. Let me do that differently. Now, if you're a student, raise your hand. All right, students, to be commended. You're giving up your Tuesday night. I don't know how Fortnite will survive without you, but you're doing it. Okay. So, tonight is, again, my name is, so we got an equal bunch of teachers and students, and that's just fine. This webinar is being recorded, and the presentation slides will be shared down the road. Okay? So, I'm looking to make sure there's no questions. If during this right now there might be questions, so Kimberly just raised her hand. Kimberly, if you would, right there where it says questions, write your questions down there in a block. If you've got a question, write it there. And sometimes people click on the hand by accident, so that's no big deal. It's all good. There'll be 4 webinars. If we need to, we'll have more. Now, let me explain something here. I will not, if there's specific questions that relate to the event, I will answer them, but I will do it in such a way on a frequently asked question page. It'll be answered to everybody. So I can't answer. I've got to be very careful not to unintentionally give one team an advantage over the other teams. You wouldn't like that if it worked against you. So we don't want to do that. And I know, and then you don't want that. If you win, you want to say, hey, I did it. You did it all on your own. So for lots of reasons, that's just the fairest thing to do. But let me describe what the event's going to be and why we're really excited about doing it this way. In years past, we've done this event with the Raspberry Pis. We love Raspberry Pi. I was the first school in the United States to use Raspberry Pi. My claim to fame with Raspberry Pis. Used them in a classroom setting. Met the Uptons who started that, and Charlotte, the whole 9 yards. Well, we don't use the Raspberry Pis anymore. We're going to do this virtually so every school can participate. And so one of my goals, as I say, I'm a school teacher. I teach at Charlotte Latin School. We're here in Charlotte. It's a K-12 prep school. I've been teaching engineering now for over 30 years. I teach at Charlotte Latin. I've been involved with the Science House, the North Carolina Science Olympiad, actively involved in the maker community. In fact, I'm not only involved very much at my school, I'm our Fab Lab director. And we all have a program affiliated with the Fab Foundation, which was created by an MIT professor based on a course on how to make almost anything. So we have a maker space that's almost like on steroids. We can make 95% of anything. And in fact, before I taught this class, before the webinars tonight, I was at school with a new class of people taking how to make almost anything. So very involved with engineering and things. And in the course of working with the Science House and another program called Young Engineers of Today, or Engineering Enrichment Program, wanted to start teaching kids mechatronics. And if you're saying, well, what are mechatronics? We'll get to that in just a minute. It involves, for example, we use Arduinos. But if you have Internet of Things, it involves mechatronics. 3D printers involve mechatronics. Drones involve mechatronics. It's a combination of programming, mechanical engineering, electrical engineering. So that's what mechatronics is. I think it's very exciting. It's the basis behind all robotics, and we wanted to include that in the Science Olympiad. The issue gets to be with some of these things is, well, how can we afford to have everybody have all the electronics? We've come up with a solution. We're going to talk about that a little bit later so everybody can practice. This is also good for future events when you want to use Arduinos. So there we go. Getting started. Hello, world of embedded computing. All right. North Carolina Science Olympiad. What is an Arduino? What can we do with it? How do we control it? And tonight's goal is really just to make an LED blink. We're all familiar with light emitting diodes and lights. Very efficient. Okay, so what is an Arduino? Well, these are all forms of Arduino. They all involve hardware. And it's incredible. Once you start using Arduino, it's incredible. And you can make things from 3D printers to quadcopters. And they say this is a hexacopter, that's not even a quadcopter. So what we're going to do tonight is look at the Arduino hardware. And while you won't need it, you're saying to yourself, oh my gosh, what do you mean I won't need it? And you're going to teach me about it because we're going to simulate it. And if you say, well, I wish we did have the electronics do it. And I do too, but not every school does. And this is all free, so more schools can participate. I think we'd all agree we'd rather have more schools participating. If you can get this stuff, it's inexpensively. So if you're watching this, you want to do this at home or down the road, you can. You can go on Amazon or any of the sites and find this stuff. Mow a yard or two, and you'd have more than enough money to get Arduino some components. But until then, let's just do the simulator. All right. I've got Joseph raised a question. And Joseph, if you would, you raised your hand, write it under questions so I can read it there, buddy. That's with this many people, I've got to do it or we won't get there. We have now 40 folks here. So I'm going to put your hand on, Joseph. I want you to answer a question here, man. There you go. There's a little question thing. You can post it in there, and I'll gladly read it. All right, so hardware. Now, a lot of times Arduinos are blue, but they can be black. They can also be red. What makes an Arduino is this chip. Okay, but they all come with certain things, generally come with power jack, plug into a 9-volt battery if you want to, USB, the mini, on this one it's the mini, but it could be USB micro, USB B, or C. Then there's power pins, how we power this bad boy up. Analog pins, they read, think of analog. analog is a range. It's like, how bright is it outside? That's a range. How warm is it outside? That's a range. All right? Where, how happy are you? That's a range. Anything is a range, think of analog. Whereas digital is either yes or no. All right? It's anything that's either on or it's off. The light is on, the light is off. All right, and we just had our first question. I'll get it right there. How's the Arduino different from the Pi? Great. A Pi is an actual Linux computer, and it has a few GPIO pins. The Arduino needs a computer, and they do different tasks really well. This process is much faster than the Raspberry Pi does. You can make it. You can be made cheaper, but this is not a computer. It just does a microbit. But a Raspberry Pi is an actual computer. And someone just said, hey, we're just wondering if the following 3 webinars will discuss more advanced topics, or am I just going to repeat the same things? No, it'll be more advanced topics. I will make it possible so you will be able to come back and watch it. So I'm not going to repeat it. I will recommend people just watch the webinar and do it. Lorenzo, you got your hand up. If you've got questions, ask it. Okay? Now, so there's the reset button on this. And in real life, you'd have that. So you have digital pens, all these things. Whoops. That's a transmitting light, receiving light. When you upload, download code, there's pin 13. That's an LED, believe it or not. We can control it by pin 13. These pins, be it analog and digitals, can turn on things and can also receive information and be sensors. So they can do both. They can either turn on an LED or sense the amount of light. It just depends what you hook them up to. And then there's the power. So when sometimes you troubleshoot these, that's what you're looking for. So if you have a Arduino, you happen to have Arduinos at school, one thing I would troubleshoot if it's not doing anything, see if there's any power onto it. I think we solve a lot of problems just seeing if they're turned on. Is the Arduino similar to Bobot? Sorry, I'm not sure what a Bobot is. It probably uses an Arduino type brains in it somewhere. I'm used to PICs and some other things. All right, so I'm right. That would be an analog. Analog input pins. So we look at this 4, 5, 6. All right, it's a transmitting light. That tells you you're transmitting something for your Arduino, you're receiving something, and you're controlling LED 13. This allows you to, in embedded computing, Mechatronics, we think turning on and blinking an LED is the equivalent in programming of Hello World. If any of you programmed, you realize, especially it used to be particularly, that when you got a program to run, the first program you wrote was Hello World. It was your way of saying, okay, I know how to compile it, I know how to write the code, at least I can do that. Once I can do that, I can go to these other things. The equivalent of that is blinking an LED. Well, you don't always want to carry an LED with your Arduino, and that's why it's built into some Arduinos. Which Arduino board would you recommend to practice on for the competition? Patrick, I've got good news. I'm about to show you the board I'd have you practice on. And you already have it. All right. We just said, let's go here. I just went the wrong way. Those are number 10. I hope you get as the digital pins. And then those are the rest. So I'm going to show you in a minute, Patrick, what we're going to do. We are going to use Tinker Circuit and be able to pull that Arduinos off there. Now let's talk about reviewing electronics. This is really important. Okay? Because remember, mechatronics is a combination of electrical engineering and programming as well as mechanical. Everybody's asking which would be the best to practice. I'm about to show you it. And I'll show you where to practice and do all the practicing y'all want. Okay? But let's talk about electronics, because you're going to need to know this to get set on this. There is a breadboard. Last year when we did this event, and some mechatronic events, we used simulators, people were building their circuits without a breadboard. You are going to be required to use a breadboard, because in the real world, you'd use a breadboard. Or you would use what's called a proto board, or you'd make your own board. But you wouldn't just wire everything with electric tape trying to glue it together or something. Okay? And what that does is it provides a way for you to connect electronics without soldering them. Though I think once you're above 5th grade, I think you should learn how to solder. Have someone show you. We do at our school. So you have an LED and you connect said LED. All right? And you have letters and numbers, horizontal bus, vertical bus. They're all connected. And so what do I mean by they're all connected? All along these vertical buses, this ground is connected. If you connect here and you connect it here, you complete a circuit. If you here to here, you connect a circuit. If you went from here to here, not so much. You would not connect. Pardon me. If you did A7, AB, AC, they're all connected. But if you connected 6, A6 to A7, they wouldn't be connected. So right here, connected. Up here and down, connected. And you can look with this next picture, see what we mean. The red power, each sign, this is the power, this is the ground. Just remember, you always go from high potential to low potential in natural systems, always. You go uphill, you go downhill. Electricity, you go from higher potential to lower potential. So just think of the water analogy like electricity. Water, like electricity, flows downhill. It goes from a higher potential, top of the hill, to the bottom of the hill. The ground is the very bottom of the hill. It's ground. That's what they literally mean by that. All right? And your voltage is just up higher potential energy. Now, here's the thing that's wild. Connect here, goes all the way down the blue rail. Connect here, all the way down the red rail. Here, it just connects at these sections right across. Do you see in the gray? That's where they're connected. So, let me show you some things to do and not do whenever you plug things into a breadboard, including in a simulator. These are all incorrect. If I told you this rail goes all the way down, right, this blue rail, and I hook a resistor in this blue rail, it's just connecting one resistor to this resistor end, and it's really not doing anything. Because here's the thing about electricity. It always goes to the lowest resistance. Always. You know, you got to struggle through the lunch line, or you go to lunch line where no one's standing there. Same food, but there's a big long line, or no line. You're going to go to no line. Electricity is the same way. It's going to go to the lowest resistance. And so if remember on our breadboard, that's a metal roll all underneath these. See how these metal rolls are connected? And these are connected this way. If I hook up a resistor there, what's going to happen in this situation is electricity says, well, I could go through that resistor, and by definition, it has resistance. It's not a 0 ohm resistor. Or I can go in the metal underneath it. I'm going to go with the metal underneath it. Same thing with this LED. The correct way to do it along the long rails is see how the LED is on one rail and then on the next. There's nothing connecting those two rails but the LED itself. So electricity has no choice. Same thing with the resistor. It's one leg on this, the other. In fact, I'll even blow this up a little bit better. So, yeah, you can see it. In this case, the current could go underneath it and just keep going down there, or go through the resistor. Well, it's going to go underneath it, lower resistance. In this case, currents here goes over to the other side. This rail is not connected to this side except through the resistor in this example. I'm just showing you right there. That would work. This LED doesn't do anything here. It's not going to go through the LED. It can just go right down the red rail. But if you connect this arm to this arm, it'll go through there. Okay? This is why, just think, if the rail's going this way, don't put the connected components that way along it. So this is wrong, this is wrong, this is the opposite because same thing, it's wrong. This is already all connected, so is this one. Now, the correct way, as I just showed you, is go across the rail here, here. In this case, this way, horizontally, is all correct. So this is how you would connect a circuit. The ground, same as the resistor, same as the LED, back over. Okay? Now, if you're sitting there saying, wow, this is a little confusing in the beginning, wouldn't this be in a second beginning? Well, yes, because this is a little bit confusing. A lot of adults don't get this. So if you don't get it the first time through, don't worry. Now, someone said in the second example, or in the correct example, where these are really not connected to anything. We're not, I could be throwing low current through there and it wouldn't fry the LED. But yes, you should know this. If you have an LED, you should have a resistor hooked to it. So Katie, you're right. You want to have a resistor connected to it. I'm more worried in this example, just so you get to understand placement. These presentation slides will be ready for you probably after Thursday. I'll set up the slides so you can take them. Okay? That answer your question, Katie? All right. Now, fun part begins. Let's just talk about what an LED is, just so we remember. LED is a light emitting diode. They use 1/10 of the current, 1/8 of the current that a regular light bulb draws. So they're very efficient. I've said this for my own students. I'll say it for the students here. I suspect your grandchildren won't even know what a regular light bulb is unless someone's keeping it because they like the look. They're really much, much more efficient. So this is just a pin off the Arduino. We said red board, but it's Arduino. Goes through the LED, goes to resistor, goes to ground. And that's how we're going to end in a ground. So that's how we finish this circuit. I'm just showing you that. And here's a resistor. Resistors, if we use that waterfall analogy, water going down the waterfall is the current. The voltage is the push. How fast and not how fast, how much water are we driving? What kind of pressure the water is on, I would say. That is determined by how high the hill is, so that potential voltage difference. That potential difference is voltage. Resistance is like the opposite, almost like if that was a pipe coming down the hill, there'd be rocks in the hill, in the water to slow it down. Now, that's a weak analogy. That's not really a good description, but it'll work for what we're trying to do. And the reason we have resistors is because those LEDs are so efficient that if you didn't have the resistor, the LED would light up, but it wouldn't be using most of the energy, and therefore it would get warm because the energy is never created or destroyed. It just changes. So it would get warm, the LED would get warm, get too hot, burn, and melt. It'll turn bright, pop, and then that's it. So simple circuit, you go from the positive of the battery, long leg of the LED, because it is sensitive polarity, short leg back to resistor here. Resistor be connected there, it doesn't matter. And this is just, now what we're going to go through and do, I'm going to jump out here. That's enough for electronics right now. We're going to go to Tinkercad, because at Tinkercad includes 3D designs, circuits, and lessons. Now, here's the good news on Tinkercad. This is what we're going to use so everybody can program this. You can, there's all kinds of gallery, blog, learn, teach. So what you need to do is to sign into it. So let me see. I'm on, did you know schools? Check out this. And we can go ahead and do that. We can sign into it. I'm already logged in on mine, but Remember, you've got to be of age 14, or you're going to need some of the school accounts do work. You might need your parents' permission to go ahead and sign in on that. There is none. It is completely family wholesome. There's nothing sketchy at all on it. All right. It would be great if right now you could go ahead and create an account on Tinkercad. How many people have an account for Tinkercad already, or any of the Autodesk products? Got a couple. All right, we've got a bunch. Nice. All right, that's really great. For those of you, if you can't do it tonight, now, when this webinar is over, do it. You're going to need this. Now, when you go to the competition, we're going to give you Tinkercad accounts. So that way people don't come already with a bunch of things, notes and everything else. We will have that. All right. Now, when you bring it on 3D designs, if you go to here, create a new design, I'm just going to use 3D, so if it happens to you, you know what's going on. This allows us, it's like a simple CAD program. We can go ahead and draw items. We take a block out here. This is getting more and more impressive. It's getting into Fusion, but we're not going to worry about that anymore because we're not really interested in Tinkercad. Not for this. Going to back out. I'm going to go to circuits. I'm going to create a new circuit. This is what we're interested in. So I'm going to take a moment here. That's 8:28, so we'll wait to 8:30. Go ahead, if you've got Tinker Circuit, go ahead and bring it on. Give everybody a few moments here. Tonight is really just going to blink an LED, and then we'll stop and talk about the competition a little bit, and then we'll come back and get into more advanced things Thursday. Let me see if there's any questions. I used Tinkercad a while ago. Is it still a free program? Yes. For Tinkercad, do we need to put in our real age? I would rather, well, if you're above age 15, you can sign right in. If you're under age 14, you're going to need your permission for that. Now, some people put down that they're born in 2000, so they just can get registered. Yeah, can you access the PowerPoint after the webinar? Yes, I will have it available for you Thursday. Okay? Is a competition. We'll be using the block code, the text code, or different code. Block code. Is it illegal? Is it illegal for what? No. Tinkercad is not illegal. It's free software. You're going to be using block code for the competition. My teammate isn't on today. Will you recap briefly on the next webinar? Eleanor, what I will be happy to do is share you a link of this video. so you can look at it all you guys want. How's that? And we'll have a quick summary, but I would recommend watching the video. Where do we go on Tinkercad? You go to Tinker Circuit. When you go back over here, I'll just show you again. It comes up. You can go to 3D design. There's like lessons here, which we're not going to worry about. All kinds of private lessons. I was playing with those, but let's go to circuits, create a new circuit. Thank you. I'll force and watch. Yeah, awesome. Can you use text? Use text? No. You've got to use code and fairness. I love text too, my friend, but we're going to keep it simple here. When we bring Amazing Mechatronics back in another U2 again for the high school level, you'll be using text. Will we go into bytes, bits, and things related to serial in the next class? I'm not sure about that. Not sure we're going to do that. Remember, you're obviously into that, Son, but there's a bunch of people here who have never done this before, and that's who I'm really helping the most. You're asking the same question over and over again. We are using blocks, folks. Everybody, we're using blocks. We're not using text. Remember, some of you have been programming a while, and I know would thrive using text. But there's a bunch of kids this competition is aimed at to get them introduced into programming. We're going to start off with blocks, okay? So don't worry. I know, and again, I appreciate your enthusiasm for text. But remember, there's other people, okay? We want everybody in there. The more people get into this stuff, the better off we're going to be. All right, everybody. Let's go ahead. And I'm going to start you off. There's all kinds of programs in here, Arduinos and stuff, and they'll have examples. You see how they're all connected without a breadboard? For the competition, just so you know, you're going to have to connect everything to a breadboard. That's to get you all using breadboards. So when you go off to college engineering and programming, you'll do well there because you're going to use breadboard. When you're first prototyping something, the quickest thing you do is use a breadboard. So just first things first. Here's a breadboard. I'll pull this one out. Oh, I don't know. Is it because the webinar, but mine is going very slow here. All right, so there it is. Probably the webinar. And see how it's going off? Yeah, see now I've got two of them showing up because it was so slow. So we're going to do one thing at a time. And it's just saying, hey, you're about to delete a bunch of components. That's going to mess things up. Say, okay, I don't care. I'm going to delete. All right, so let's go back. And I'm just going to go to, in this case, I'm just going to pull it out. I'm going to go all components. Though you could have gone basic. I'm going to go all components. I'm going to look for an Arduino. And I start looking through there every day. It's interesting to me. I always come down there. I see more and more stuff showing up. Like now they're using 5.5 terminals, all this stuff. They did not have integrated circuits just that long ago, and now they're doing it. And it's really very exciting. Networking stuff, logic gates. This is all new in the last month or two. simple motor controllers, AT Tiny. Those kids that are really into this, folks, if you're saying, I want to do more in code and objects, start learning how to use an AT Tiny. That's the brains that are similar to what's in an Arduino. Only you can get these for the fraction of the cost of a whole big machine. All right. So anyways, so first things first, let's get a breadboard mini. We're going to drag it out here. And you can change, that'll work for what? Let's see if we can get, I'd rather do power rails. Let me drop that off here. Let me right click that. Sorry, let me do it this way. I hit delete. Let me get the other breadboard. So I'm going to go search a breadboard. They also, this is cool. They also, in their, this is what I was looking for, breadboard small here. Let's grab the, all right, great, because I want the rails. This is going to have the rails. Notice when I click on that, see how it's green? You see it's all connected there. All the red rails are connected like that, and these are connected horizontally. So they'll show you where they connect. All right, and then I hit rotate, and you can see these. So I hit R, and I can move it over just like that. In this case, I might move it over here, but right there. And then I'm going to go over here to Arduino, type in ARD, and it'll show up. All right, so put Arduino over here. We're using it. Let me see if I can get this to show up. There, that's great. Notice the cable on the end of that. When it turns on, I'm going to move the breadboard over. Let's escape off that. Grab it by the center of the breadboard. You can move it. And there's the Arduino. So you were asking me earlier, everybody, everyone, this is the Arduino use. Just use the simulator. You don't need to buy it. This is why we did what we did. So everybody, everywhere, no matter, since this program's free, most everybody has access to a computer somewhere, you can practice for this. And in my lab, we design everything on this, and then we'll make it off the breadboard, and then we use text, by the way, and we even go down to more base language. We write it in C sometimes. But we often, most of the time, we're using Arduino IDE. It's development environment, folks. Integrated development environment, IDE. And when you go to Arduino, and that's what you'd see on the text of this. So here we are to an Arduino. I'm going to grab it right here in the middle. I'm going to hit R. So here it is. I'm bringing it down so when we go to run the simulation, watch, this will plug in. If I hit start simulation, plugs right in. All right. Now, let's go get our LED. Type LED. We're going to take an LED and we're going to put it right here. All right. And we're going to rotate it. Because remember, Mr. Dewick just said, we want to make sure when we hook this up, it has to go in this rail, then out this rail. That's the anode, that's the cathode, that's the negative. Now, what we're going to do is we're going to use, in the beginning, our Arduino, just like if it was a battery. So can everybody be doing this? Get your Arduino, get your LED, put it right there. Okay? Let me let everybody get that shot. Is there any other programs we use in case Tinkercad is blocked on our school campus, or we should bring our home laptops for science Olympiad meetings? First of all, ask your IT department to unblink Tinkercad teachers, or if you guys, this is for totally educational value. I hope so. I'm not, believe me, whoever's asking this, Eleanor, this is not directed at you. I'd be very surprised if the school is not going to let you use Tinkercad Tinker Circuit if they understood what it was. All right. How do I rotate? Great question. Click on the thing and just type R. So if you click on it, don't click on one of the dots. It's going to think you're trying to put a wire. And if you hit R, Swing it right around. Just keep hitting R. Except I did it too quickly. All right, there's R. Okay? You right-click on it and delete it. Right-click on it and you can also hit the delete key. Somebody asked how I remove a wire. I'll show you how to do that in a minute. So first thing is we're going to use this just like a battery. So I'm going to click on this 5-volt. I'm going to pull out a wire. It's green. Click it there. I click it again. Pull it up to here. Click it. Bring it over. It's 5-volt. We're going to make it hot to the red. So click here and put it right in there. And since it's 5-volt, I'm going to make it red. So I know that indeed. There we go. And then I'm going to hit the ground. Go on the outside of the red. There. There. There we go. Make that black. All right. And I can use my mouse to slide in, zoom out. Now, if I start the simulation, that plugs in. This little green light comes on. Notice that's blinking because that automatically comes in the program. We're going to hit stop. Once you have this, folks, so the wires are there. Can you everybody raise your hand that's gotten to this point now? Excellent. You guys are a bright group. Well done, folks. Well done. All right, now we're going to run power to our LED. But remember earlier I said, oh man, don't just run power to an LED. A great student really observed before, hey, you ran power to that LED, you'd fry it. You're absolutely right. So we're going to go over here and type in resistor. I'm going to grab that resistor if I can. I'm not going to put it there. I'm going to move it. I'm going to put it right on this leg of this resistor, of this LED. They're on the same row. See how that green's there and it shows right across. All right. Now, what size resistor is this? Well, we can look at it. I don't know why it's not. There it goes. If you click on it once, it'll sometimes come out. It shows 1,000. That's a little too high. It's too much resistance. We're going to move it down to ohm. 1 ohm is not enough. Let's just make it 300. And you'll watch, the resistor will actually show the difference on the code. So now the resistor is 300 ohm. And that shouldn't fry the LED. Then I'm going to collect 1 cord here. That I'm going to collect to the red because this is going to go down this resistor, the positive leg of the LED back to this ground. Since that's red, I'm going to keep it red so it helps me understand what's going on. Then I'm going to click here to the ground. I am going to go black. That's positive, that's ground. Let's go ahead and start the simulation. Look at my LED came on and it didn't break. It'll actually show like it's blowing up if you didn't have that resistor there. All right. So right now kids are trying it without the resistor to see what happens. So go ahead, put your hands down. Let me know once you've all raise your hand once you've got it working this way. All right. Well done, folks. Well done. We have 41 people here tonight. Well done, folks. Giving up on your Tuesday night for this. You're to be commended. All right. Now, we could use the Arduino like a battery, but then we'd have to unplug it or plug it anytime we wanted the LED to turn on. And we couldn't flash the LED. Everybody likes a blinking LED, and I'm not going to stand there and unplug and plug in this Arduino. So what to do? Well, let's do this. instead of going to this ground like this, let's take this wire, grab that end of it. It's no longer I'm going to move it to pin just 9, just to 8, just so we can write our code to this. So I'm going to plug it to 8. So 8 goes on here. I start the program again. But alas, there is no LEDs not lighting up anymore. So we're going to code it. All right? So make sure everybody moves their pin, their LED, this wire to pin 8. Don't worry about this rail anymore. Make sure it's there is fine, but keep the ground there. But this one you move to 8. We're going to use this digital pin to turn this LED on and off. So I'm going to go to code, and up comes this. All right, you see that built-in LED at high? Remember I said before this LED at pin 13 would go on and off? So we're going to set that to high, wait a second, 1 second, low, 1 second. Watch the simulation. Watch what happens. See the LED? It turns on and off in a second. And if you think, well, how do we know that's the case? Stop the simulation, and I'm going to make it blink faster. I'm going to make this 0.5 and this 0.5. Now start the simulation. So now it's blinking faster. This little bit of code is doing that. Okay? Could you just have rotated the resistor and it would have been worked? Yeah. Do you know how powerful your resistor should be? About 300 is good. Can the resistor go on either side of circuit? Yes. Does not matter. It can go on the power or on the ground side. It's more like pressure, the way to think about that resistor. And the pressure is constant throughout the line. Again, my true electrical engineers are cringing at some of these descriptions, but it's apt for what we're doing. All right, so my next question is, we don't want to blink that LED pin 13 anymore. We want to blink what we did. So what I'm going to do is pull this out or pull this down. I'm going to make sure the simulation stopped. I'm going to take this, drop it off over here, and then I'm going to set pin. We're going to use 8 to high. We're going to wait half a second, set pin 8 to low. So now we have pin 8, pin in the load. I'm going to hide the code and then start the simulation. And there's my LED. Uh-oh, did something wrong because look at it, just turned on, but it's not. So I'm going to go back and find out what the heck happened. What did I do wrong? Let's hear the code. Oh, because I need to set this to low. See how that's high and it's low. Let me hide my code again. Start simulation. There it is, blinking. And in our world of mechatronics, that's the same thing as saying hello world, because if you can do that now, you can get it going everywhere. And in case you think we're still hooked up to the 5 volt is doing anything, stop the simulation, go to that 5 volter, right, you can just hit, see how it changed like that? Just hit delete. The program will run fine. Because this is containing the 5 volts, the higher potential running through there. My memory said, but the LED does not work. Flip the LED around. So either LEDs are very sensitive to polarity. They're light emitting diodes, but diodes are very to polarity. All right. Yes, folks, you're all asking the same questions, making me let's smile now. Yes, Katie, pardon me. This is the software you will be using at the competition, and we'll be using block code. All right. You don't need to buy any hardware. This way, everybody can compete. Make sense? All right. Now, in the few minutes we've got left here, let's talk about the competition. It's going to be divided into two halves. First half, we're going to show you electronics, some code, a sheet of paper, and you're going to be asked questions about it, and you are going to tell us how to fix it. So we'll tell you, hey, it's supposed to blink 3 times. It's only blinking once. Tell us why and how. Then that'll be half. And then half, we're going to ask you to make things. You will not be able to bring in, you will not go and log in on your account. You must, in all cases that you're making things, use a breadboard. You just can't wire to the object. That's to encourage you to use breadboards. Because in real life, you're going to do that. Any kind of really elaborate. All right? Lorenzo, the resistor can be set at 300. 330, 400, 200, it'd be fine. Any other questions about the test? So, again, series of questions, coding. So the problem could be in your programming, problem could be in electronics. You're trying to decide which is which. All right? Okay, then. Any other questions before? I'm going to see you Thursday. We'll record this. Give me a date. I have to download these things and get them all ready to be uploaded. Once I do, I notify Mr. Vasey, and we'll get them out there so everybody can watch them. And then as we get through this, I'll send you a card. Will physical hardware be used in competitions? Guys, again, we are using the Tinkercad software, everybody. We are not using hardware, so kids can all have the same opportunity. Yes, in past, you have a very valid point. You say, well, in the past, you sometimes use hardware. We have. This way, we're going to use the software. So it's going to require that we have a computer lab. Okay? So no worries, folks. It's all going to be good. All right. Lorenzo, yours won't come on. Well, that doesn't tell me a lot. I don't know if you've started the simulation of the code. Does your code look like this, buddy? Set pin 8 to high. Wait 0.5 seconds. Set pin 8 to low. Wait 5 seconds. How do you set the resistor? You click on it once. You have to kind of kick on it a little funny, and then it'll come up, and then you can set the values then. Lorenzo, did you get this code right? Hey, Lorenzo. All right, good. Good man. Good job on that. Now, let's go over. I'm going to close it. What I'm going to show you is you follow this around. You go from the ground to this black rail, from this black rail to the cathode. Put your mouse over. Make sure it's cathode. And then resistor on this side is anode to this terminal to this resistor. Now I clicked once and it came up. It's 300 ohms. Make sure it isn't 300 this. Because if that's the case, it's never going to turn on. Or, well, it's vaguely turning on here. I'm surprised it's turning on that much. So go back to ohms. Now it's much brighter. Then it goes from this resistor on this column right here. See how they're all joined? Back to pin 8. And don't worry, this is going to be recorded. You can watch it. Yes. There we go again. You must use the blocks. You will be disqualified if you use text. What's the value of this resistor set at? 300. That's what is wrong. Oh, so you figured out what you did, Lorenzo? Good. I'm glad you figured it out. Okay, I'm going to show you the code, but it could be your hardware, kiddo. Make sure it's that. I'm going to pull it over so you can see the code. Stop the simulation. There's the code. But make sure. I'm going to back this out. Oh, no. My mouse is acting weird. It should zoom in, but it's not. That's a little bit. You can add it out. You can put notes all over this now. All right. So here's the code. Set pen to 8 to high, wait 0.5 seconds. Set pen 8 to low, wait 5 seconds. Where are the digital input pins? They're all along the Arduino. I can't get this to zoom in now, which is a little bit annoying. Almost to the point of let me see if I can get out. I'm going to try to get back into it. Hopefully it'll bring it back up. Going to go into Tinkercad. All right. Also, I would get in the habit of naming these things so you know what it is. Here it is. Hopefully it's going to come up. Tinker this. There we go. Sometimes it's faster just do this. So if I go to that, there's my code. There it is. I might have lost my code actually. Let me see if it's still here. Nope, there it is. There's the code. Right there. All right. Any other questions? Will the code be used? Yes, it will be block coding. Molly, you got it. Good. Yep. Hit the refresh screen. Sometimes it's just the refresh in their Tinkercad. Good point, Ben. All right. You all have been a great audience. There's 42 of you here. Well done. This will be saved. We'll show you what's going on. And I look forward to talking to you in the future. So I will see you back here Thursday night. Bye-bye. Oh, wait a minute. I've got some more questions. Is there a way to make the circuit not repeat endlessly? Not really. Once you get it going, in this case, no. How do you get black wire to go around the board? You double click. So if I go here in this ground, I'll just pull a wire out, come here, click once, go up here, click once, go around here, click once. Now I'm going to stop there and get rid of it. You bet. Thank you. You've been a good folks. I'm really impressed with all you kids that are writing text on Arduino. Good job, guys. Unfortunately, you can't use it for the competition. Okay. Well, with that in mind, everyone, take care. Bye-bye. When will we be learning Scratch? We're not going to be using Scratch. This is what we're using instead this year. All right. So everybody have a great one now. I am going to end it now, if it's okay. All right. Bye-bye, all.